Hey there. So, we all know that AI agents are powerful, but they're not perfect. Sometimes tools fail, APIs crash, scripts break, but a smart agent is not the one that never fails. It's the one that recovers. So, in this video, we'll exactly build a fault-tolerant OpenClaw AI agent that can detect a failure, retry automatically, and switch to a fallback model when everything else fails. So this is all possible just through OpenClaw commands, and I'll be opening my PowerShell here. So before you execute anything, you have to run your gateway. So whenever you run your gateway here, you can see whatever all your command logs happening. And after this, we need to open our Linux here and we have to check our OpenClaw version. Okay, and then we have to check what is our model list. So our model lists are basically Google Gemini models. So currently I'm using Gemini 2.5 Flash Lite. So what is the problem here is that whenever an AI agent runs tasks, failures are very common. They can be network errors, missing files, tool crashes, API rate limits. Now without recovery logic, the agent simply stops. That means the task has failed, workflow stopped, automation broken. Now, to implement these three reliability mechanisms, we need to focus on retry logic, back off timing, and then we need to focus on fallback execution as well. Right? Now, we need to once create a script that always fails. Okay? So before that, what we are actually going to do is that we have to create a script here. Sorry, not script. We have to check whether our gateway status is okay, whether our health is good, and we need to run the doctor command. Okay, so whenever you run all these four commands, you can see that after these commands get executed, you can see that your doctor is completed, and then you can apply your doctor fix. And after you apply your doctor fix, we will basically create a backup tool here. So this creates a backup tool whenever your fallback systems are critical in production. Okay, and then you can export this here. Now basically this is the most important one. We are creating this as a backup tool. Now we need to create a fail script. Okay, we need to create a script that always fails. So this is our script. This is the script. Remember, fail tool.sh. This is our script we are creating that always fails. Then we execute this and then we run. So see, running tool simulated failure. Okay, and then after this we need to create a fallback tool. Now why we are creating a fallback tool? Because we need a backup tool that retries, that runs whenever all the retries fail. So this is our backup tool here. We compile it again like fail tool, and then we execute it again. Okay, now after this we have to implement our retry logic. Okay, now we create a recovery controller. So after you create a recovery controller, you have to execute it via OpenClaw agent here. So we are executing this via OpenClaw agent. Okay, so when you execute it via OpenClaw agent, see, these are some of the things you need to enable it here. Okay, so whenever you enable it and run it here, so this is our actually the command. Okay, this is our failure command. This is running. Okay, so this is our fallback tool as the fallback tool script. Okay, and whenever you run this fallback tool and recovery tool, you can see that the fallback tool executed successfully. And similarly, if you want to make any changes, you can make it here. Okay, if you want to check whether your retries are failing or executing, you can check it here. And when you run this command of recovery runner.sh, you can see that your fallback tool has been executed successfully. And similarly, you can attempt it. Now, if you want to run this by OpenClaw, you need to give a message here at first. Okay, so this is our message. We are giving it here. OpenClaw agent main message, execute this. Okay, and after it execute, it will give you a response like this. I have already attempted to execute and all. Now, why it is giving like this? Because instead of failing, these agents retry your tools automatically and switch models. So this is expected. You get this message every time. So what in that case you need to do is you need to basically allow a group runtime of this thing. You need to allow, you need to actually allow group runtime. What is this group runtime here? So group runtime is basically parallel or distributed systems where it refers to total execution of group of tasks running. So whenever we want a group of tasks to run, whenever this gives a fallback error, we run this command. After we run this, we need to check whether our configuration is containing group runtime this or not. So yes, it's containing. Now again we'll run this command. See, your message also matters. So whatever message you're giving, like running a bash command of this actually tells your OpenClaw to execute that particular task itself rather than executing total tasks running together. So whenever you run this, you will get an output of this thing. So we got successfully the output as the tool is executing this time. It appears that the script now has the access to the necessary supporting files, allowing it to complete its execution, including the fallback. So you can have a look at this. So what we are basically doing is that, let me show you the architecture here. Okay, so let me open the architecture and we can see. So whenever your agent comes here, okay, this will basically try to run your tool. Okay, so whenever it tries to run your tool here, what will happen if your tool fails? Okay, it's a fault tolerant flow execution system. So whenever your tool fails, the tool, uh, maybe the errors can be network, API timeout, missing file and all. So this will go for retry mechanism. So what we have done, we have created a failure script here. Okay, if I go to the top, you can see I have created a failure script here. This is a failure script. Okay, create a failure script. Okay, what you have to do, you have to create failure script and fallback script. So when you create a failure script, this will automatically retry your attempts, and when this retries get exhausted, okay, this means all your retry attempts fail. We have created a fake retry file here. So in the actual world, whenever you get this kind of situation, you have to remember that whenever your tool is consistently failing, the system stops retrying to avoid infinite loops. Okay, and as a result of this, what happened? Your fallback tool runs. Okay, so this means your system uses an alternative tool to complete the task. For example, here we can see API request, web request, and all we have kept here. Okay, I'll show you the tool back. So see, we have kept a failure script. Okay, and then see, we have actually run the fallback script as well. I'll show you the fallback script here. See, this is a fallback script. Okay, see, whenever all your retries fail, this will execute here. Okay, so you can keep a fallback script in a similar manner. You can use it for API request, web scraper, AI model, and etc. For that, you will be using this. So whenever your workflow completes successfully, what will happen is that this makes a system more reliable, fault tolerant, and resilient. Okay, so that actually means that whenever you run the tool, your tools fails, it retries multiple times. When your retries exhaust, it becomes a fallback tool, and then your workflow completes successfully. Now I'll tell you a real world example. Imagine you have a sales data pipeline. So in your sales data pipeline, what will happen? Your agent comes, okay, it will fetch sales data, okay, and when that API fails, you retry it multiple times. You retry n times. Okay, so whenever you retry it n times, you still it fails, right? And still when it fails, you again go for fallback. In fallback, you can either do like loading CSV backup, and then you continue analysis. So this is one of the example. And why this design is important? Because it's widely used in AI agents, microservices, data pipelines, cloud systems, and automation frameworks. That benefits are it prevents system crashes, handles temporary failures, and ensures a task completion. So in this way, you can execute one of the most important fallback system, in which you can prevent error handling, and all those things can be happen very much quickly here. So what is the benefit of using this is basically whenever, even though your main tool fails, the system still completes the task using the fallback. Okay, that is why we use that in distributed systems a lot. Whenever a broker agent fails here, we use a fault tolerant system and resilient system to make the AI agent more and more reliable and fault tolerant and powerful. That's why we use a primary fallback model and primary model, which can be like a fetching sales data and all, and then a secondary model which is a fallback model that uses loading the sales backup data and all. So in this way, you can actually execute your error handling in a very efficient way without wasting much resources. So that's all from my side. Thank you.